Hello, welcome to this behind the scenes video series which documents the design process of a Eurorec module. This is the module itself in question, the tràigh transistor ladder low pass filter, which I originally designed as the second module that I launched as Instruō back in 2016. So this is the original here, but I revisited recently for this project. So I'm working alone in most of this video. This was the Sunday, the next day. And it's probably about a 5 or 6 hour session, I think, of just straight PCB routing, because the schematic was all done with myself and David the day before. So yeah, this is me occasionally talking to myself on camera, and I've done my best to sort of condense time where I can to make it a bit more abridged, a bit more concise. Yeah, not a lot of chat in this video, but I'll maybe interject or like put over some text descriptions of what I'm working through at various points. Hope you enjoy. Okay, coffee is made. I'm ready to start some PCB layouts. Hey doggy, good boy. Okay, so I did a bit of a look through this morning. Just switch over cameras. Okay, so I did find some not insignificant mistakes in my schematic from yesterday. So I just did a quick look over that earlier this morning. I had this capacitor connected there when it should be connected there, which yeah, that would have been somewhat catastrophic for its behaviour, I think. Other than that, it was just a few value definitions for resistors that I'd missed, or just like copying over a resistor somewhere in the schematic. I hadn't revalued it. But yeah, that should be good to go for actual PCB routing. So I'll keep the Eagle file open just in case I need a reference. I could always look at how I did it first time round, although I'm going to be redoing this entirely. I've got more circuitry to add in. Chips are different sizes. These are all discrete transistors now, so I'm not using the ICs. So yeah, complete do-over. I'll keep that there, move the schematic there, and work on the left side of the screen. So the way that I work with the Wacom tablet, the pen tablet interface, is it's mapped point to point, so it doesn't do the sort of trackpad scrolling where regardless of where you go, you're resetting the origin each time. So this is kind of the more, it took a bit of getting used to, but I think it's ultimately the better way to work with a tablet interface like this. And I've got this set corner to corner to just over halfway down the screen. So you can see my rightmost edge, I've got the mouse cursor like just a little bit further over than halfway. And I found this took a bit of just finding the right sweet spot, because all of the templates were like just half-size screen. I could map it to the entire screen, but it's kind of too big a screen to make it feel natural. I'd lose resolution on the x-axis. So I found that this works. So the way I've got this set up in particular, there are two clicks, 2 buttons on this. So the bigger button, that one there, is, if I hold that, it's the equivalent of a middle mouse click. And that lets me anchor point and drag around. So navigation is really quick. And then, not actually sure if I'm using anything for that smaller button, but it's just I think it might be like it's right click. If I hold the smaller button, my thumb, and then tap, then I get it's the same as a right click motion. But other than that, it's just click and drag, the same as if I was using a trackpad, which this whole thing is just a big trackpad in itself. So if I go over like that, I've got the same gesture. So I've got like three finger tap for drag, 2-finger tap for right click. The same way that I have the normal trackpad. But I actually have the trackpad over on the left hand side, just off camera. But it means that I can use this for additional navigation. So left hand's going between keyboard and the trackpad that's down here. And that's kind of the setup that I've worked with for several years now, and it does the job. I find it quite natural. It took a bit of getting, building up the muscle memory, but it's definitely paid off. Okay, so let's think about where this stuff is going. So yesterday I laid out the skeletal faceplate, all the mounting holes, and they're all should be named to ground, I believe. I think I did that. Faceplate. Yeah, so here are the 4 mounting holes. These 4 here. They're connected to ground. These are all non-plated through holes or rectangular cuts. And then all the jacks are vias. And they're all connected to ground as well. So actually on the back of the board, there's no copper fill in at the moment, so that dark spot there is just a stop mask shape. So it means when I've got a full copper pour in the back, that'll all be common ground across the whole back, also connecting with the 4 mounting holes. So the faceplate itself is conductive and can act as a ground plane. And all the parts look like they've pulled through correctly. Yeah, looks good. All right, let's go. Power header, that will be the only thing that I'm going to flip to the back side and have on the reverse. I'm thinking I might actually put it somewhere down at the bottom, because new circuitry, I've got the flip-flop section, which is here, that guy there. So if I pull those together, that's them. So that's going to be intercepting the input signal from this jack, like that. That's going there, branching off there. So I can do that as a quite condensed cluster down here, and it's regulated itself, so it's got its own 5-volt regulator, so I can pull that in as well. That'll be all this stuff. That is the bypass capacitor for the power pins of the 4013. Let's pull them together as well. There's that, and here we go. So that's my entire 5-volt regulator and flip-flop divider circuit, and that will neatly fit in the bottom corner there. Because I'm doing these all top side. So like physical space wise, there's plenty to cram that in and around this bottom corner there. Means I'm going to be running, say I have this here as my power. Other things I need to consider, that's linear FM through an attenuator, so that's going to be a trace that's going to run up to the main circuitry. So if the main filter circuit is up here, and get the transistor ladder all neatly configured. Trim pots, these actually pertain to the volt per octave input, which is this guy. So that's actually not too bad for placement, so that will be correlating to stuff around here from the input controls. Course, frequency, so let's view this stuff here. That's all together. Yeah, this is going to quite neatly dictate itself, I think. It's not going to be too out there a layout. So let's rotate that so that we have the key on that side. That means the red stripes on the bottom matching that arrow. Yeah, I think that'll be neat. Let me move it up slightly just because that's like quite a little bottom edge. Although within the shrouding, that'll actually be fine. It's if I was doing non-shrouded headers, then I might be tempted to move it down there. But the sort of bottom of the actual power ribbon itself would potentially extend below, so that's where space constraints might come into play and not move too close to the rail. So leaving it there, that should be plenty. Power stuff. Let's do all these actually.
let's tidy this up. Let's do hide fab back, and user 1, user 2. So this is the way that I've been drawing up footprints in KiCad, is I use user 2 layer to show the part value. So any resistors will have that clearly shown on top. It's kind of a rollover from how I did it in Eagle, where I would put the value or the designator bang in the middle. So if I'm printing off a map for doing hand assembly, all the parts are right on the origin. I found that clearer to work with. User 1 is designator, so they're slightly off. So they are, I placed them in positions that it would make sense if I was putting them on the silkscreen ledger, or I can export just a reference designator layer for the fab house, so they've got a reference point of where it is. Yeah, it's quite neat. And fab layer is, so that's a non-visible layer, so that does export with the Gerbers typically, I think, the way that I export it all. But I can hide all them just now because I don't need to see them. It keeps it a bit cleaner for dragging stuff around. So the mixer circuit I can put around here. I wonder if that is if the TSOP is the best option. Oops, TL75, don't think that's a thing. Okay, they have them in stock, that's good. I could potentially use the I series, the H series, sorry. They are vaguely stocked. That's fine, cool. Okay, that's grouped, good. So here I can hide particular nets. So I'm going to hide all the power ones because I know they need to be connected anyway, but I'm trying to place things as efficiently as possible for the main circuitry itself. So I think for neatness, just in terms of routing, if I have the ground pin over the other side, that'll just give a cleaner path. Yeah, I mean, there's plenty of space around it, but I can use this to demonstrate how I do this in KiCad, because I've got two versions of this particular jack where it's either ground on that side or ground on that side. So a few ways this could be done. I could edit the footprint itself kind of locally to this project. I tend to, it kind of doesn't matter either way because the parts get saved into the project. It's not reliant upon, the project self-contains the library, so it's not reliant upon dependencies of like a library that stays correct for this. So, but I like to do it this way where I'm editing it at the schematic level and choosing S2 as the alternate version. So there, I know the name of it, but I could also click on this and search the actual part. So that's the one that I used previously. I'm changing to S2, which has the sleeve pin, the ground pin over the other side. So do that, save, and back over to the board. And it's this command here, which is update PCB from schematic. I've got that mapped to F13. Take that, boom, flip them over. I'll keep that one where it is, why not? Okay, that's nice and neat, I think. So here I might actually want to move my 5 volts up a bit because 5 volts is here, so I will need to connect from here to there, so I can do that running this side. So there's, you know, a kind of personal challenge, I guess, is the board like this, it doesn't really matter either way, but if I can get it down to as few vias for the main circuitry as possible, so that comes down to component placement to try and get them as elegantly organized as I can, so that we don't have them all over the place. So this is my LED driver. So this is new from the original, because these LEDs were just fixed on, I think just like a 10k resistor or something, hugely under limiting, so they were painfully bright in a previous batch. So I would change the resistors by hand a lot of the time, so they didn't completely ruin your eyes. This one, they're going to be dynamically driven by amplitude. So, actually, let me just double check. Signal 4, yes, that is post attenuator. That's what I want. So yeah, I think if I put this here, that way I can have it quite central to the 4 parts. What I'll do actually while I'm at it, cathode, anode is down here. So anode and cathode are there and there. So it means if I change that one to being 8, 9, 10. So here, if I just select that, hit M for move, it moves it without moving the nets, versus G for grab, which lets you move it while staying connected to the circuitry. So let's try flipping these first. Okay, that's there. Then if I go with this one being the top, that's correct, and I might flip these ones. So if this one's currently on that fader, I'll change that to this fader, then everything's kind of just branched out more neatly. So that will be 1, 2, 3, 5, 6, 7. Nice. I'm going to throw the bypass caps in by that op-amp while I'm at it. Oops, wrong box. Power. Okay, so let's go with this pair. Yeah, that'll be good. I guess that might be a better solution. If this was that one, then that was there and that was there. That's maybe a neater thing, so I'm not having to, because it depends on where I'm pulling in that ground pin. Those are coming that way. I guess that could be there and this could pull under. That might be a neater way to do it. I'll do that, so I'll flip them back. 1, 2, 3, 6, 7. I keep forgetting about my coffee. And that can go there. And that's the input stage, output stage. So these, this is where I need to make some decisions for ease of. Actually, that's easy because ground's there, so ground's on that side. Yeah, okay, that's cool. So check this out. So this is the input 1 fader. So that will be pin taper moves, which is pin 2, and that goes towards 3, which is, oops, there. So that's pin 3. The taper is pin 2, which is there, which is what I need to branch out to my op-amp. And pin 1 is ground, which is down there, but ground's going to be common anyway. So I've got these extra do not place 22k resistors, which are going to add the audio tapering, the log tapering or anti-log if I want, depending on, or tan H if I want. But it means I can put them close together to that too, so they're going to be top side here, which is quite easy to place, which means that might not be the best place for this TL074 if there's going to be resistors here that need to connect to this. This is where it gets messy, because like these are traces that run all the way up there, all the way there. But I'll have the taper from each. Oh, these ones. It is meant to go to that point there. I guess I could branch them under and like bring them past there. That could work. Quite a tight space to run them. Two would go, I guess if that's there and that's there, there's actually space under this IC to run that way. Yeah, that would totally work. I'll do it that way. Okay, cool. So let's pull these over. Because these I'll need to either add or remove by hand as I'm as I'm going. Get plenty of spacing. That's good. Okay, it's 1, 2. Here's a fun trick as well. So if I know what this distance is, 12.7. Just plug that in there. I can get these in exactly matching positions by using this guy as a reference. What's going on? So they're moved exactly on top, but I can isolate just them by selecting them in the schematic. There and there. And then move them exactly by 12.7. Perfectly placed. And we'll do that once more. This is really handy if it's like a bigger repeating circuit of like, you know, parallel groupings of CV buffers or something like that, which is the same circuit multiple times. I can lay things out, place everything on top, grab it in the schematic, and then move the whole group elsewhere. Never really found an equivalent trick like that in Eagle, so KiCad's just got some much more efficient interface mechanics. I'll cluster these together by the op amp. Okay, so I need those other bypass caps. Okay, that's a feedback resistor. So that will come down here. I could potentially put that. I put that electrolytic on this side here. There's one thing I've wondered about this. That's AC coupling, but it's a polarized capacitor. Arguably this should be pulled up positive with a DC offset, right? Because these are bipolar signals and they're summing together, so it's going to be largely a bipolar signal summed together of different bipolar amplitudes, which means that that's going to be arguably that should be a non-polarized 10U cap. Kind of the same with a lot of these. I mean, it works fine on the tri as it is. I wonder if it's just like low enough amplitudes that it's not an issue with it being polarized. It's been working fine. I guess like arguably I could add a negative bias summing in here. I'll maybe do that just out of interest. We'll go with like a 1 meg, something like that, and have that pulled to -12, which will be inverted, and then that will mean this whole summing network is positively biased, which is then AC coupled going into the rest of the circuitry. I'll try it. It's a case of just non-populating one resistor. I'll try that. Because -12 will be somewhere here anyway. Be on that side. So I could just throw it. Yeah, just throw it there. So that connects there. I'll try that. I'll maybe just put a mark on now. Put an asterisk. For future reference. Okay, it's there. Cool, output buffer. Might as well populate that while I'm at it. So that's these two. Same deal as this guy. I'll put them to the side because that can go under. Frees up this bit for routing as needed. Whoops. Oh, that's what I'll do while I'm at it. I'm going to lock all the hardware. That. Lock power as well. Oops. Locked. I'll hide that big purple highlight as well. So now I just can't move these. Can't even select them. That's good. Although I can still select elements of it. That's good. That's quite a nice touch because if I want to set these as a reference to some other element. What's this part? Oh, that's the drivers. Okay, so these. I could put those 10Ks by the cathode, then it's just a run from that as a joint part to the inverting input. We'll do that. Okay, that branches out okay. Should move these up a bit. These are potentially do not place. So that runs there. This connects here, jumps through, that goes there. This comes down under, that goes down to there. This one now, that branches there, this one comes through, goes up. Then we have this guy coming down, going down there, going down there. And that's going to here, which is signal as well. So if I do it this way round, 1.905. It goes up there, it goes around. Yeah, I think that'll work. That would work. And this last one, which is up there. Cool. Let's do these 10Ks. They're all on that side. Cathodes are all there. That's fine. Those will be vias that will punch through. Cool. Okay. Let's figure out these jumpers. Yeah, let's put them top side. Well, I want them to be accessible to cut the traces if need be. Should put them down a bit. There and there. Cool. That'll work. Okay, now we're on to the main bit. So these all sum together. So let's place these ones first. They're pulling from those various sources. So that's coarse, fine, volt per octave, and attenuated linear FM. So maybe put them here. Try that, let's keep it quite central, and then that's got this. This trim pot here. So if I change that for this one, RV9. Where's the third trim pot? Third one's there. Feedback stage. I think this will be better suited over the other side. Like that. And this is the lower one, so if it's there. Come in a bit more actually. Cool, that's neat. Plus 12. That goes there, that goes there, there, there. Onwards. Okay, now we're on to this guy. This is the one that's got one side just not used. Ground. The speed meter is the same, they're rotationally symmetrical. Okay, here we are on to the bulk of the transistor ladder. So that's that cap, that transistor. So this can quite neatly go some in the middle here to receive from that end and that end. Ah, with that trim pot on that side. Okay, so let's maybe bring this trim pot down. Could even be like that. There, that would be the way to go. And that way it's nice and neat around as close to the inside, because the knob will be on top, so it means that the skirt of the knob will cover all the trim pots nicely. So that goes there. Okay, there's a few things here. That's what I'll do. Okay. Rotate that back. Let's go with this. Keep them vertical. Okay, so that can go there. This comes round to that trim pot. I'm not loving this placement. I think I'll move this down and put that trim pot there. Yeah, that's good, that's good. And leave this space here for the ladder rungs. Up there. This goes. What is that? That's feedback, right? Okay, so what I might actually do in that case is, doesn't matter which direction that trim pot turns, it's manually calibrated with the trim pot anyway. So doesn't really matter whether it's clockwise or counterclockwise. It's just whatever way it is. So I'm going to flip these pins, because it'll still function the same, but that's giving me neater directions for these, and that's a long trace going all the way down there from that AC source, which is further on. That's that last sort of buffer stage, which that cluster, if I move all this down, then that could be up here at the top. It depends how much space the various ladder rungs end up taking. So I mean, these I might want to bring down a good bit more to free up some space. I'll leave gap in between so I can run traces through that. Let's go up there. That branches there. Goes under. Let's connect there. It's from this source, so this could be brought over a bit. That can run through as well, so that's going through. Cool, that's quite neat. Okay, let's pull the next rung in. All there. Let's put this like that. Okay, that will limit how much I can do without vias, but that's to be expected. Okay, so that's there, that's there. Let's pull this one in. Okay, let's go up. So let's put that. 5.612. 5.612. And that's the way to go. I think that'll work. I'll get away with that. Try this. I think this might fit quite neatly. Start to see patterns. Cool. Next one. That's there. Let's do this rung. It's there. Last rung. What the last rung is this? Ah, that's the other stage. Okay, cool, cool, cool. Yeah, I think that'll work. Okay, what we got next? This cluster of stuff. Okay, let's pull these COG caps. I wonder if this might be better. There's a question. I don't know. Well, it would make sense that these are a matched pair and these are a matched pair, right? Because then each grouping of these transistors, is that a Darlington pair per side? Maybe something like that. But I guess like these being matched to those makes sense as opposed to that being a matched pair and that being a matched pair, because then they're symmetrically opposite. So yeah, that makes sense, keeping it that and that. It may be easier to route the other way round, but I think it needs to be this. Totally know what I'm doing, right? So this is that whole grouping. Cool. Okay, things to consider here. So that is, oh, that's a single resistor I can pull down. That's a plus 12 source. Let's go there. Okay, so this is a long trace for the feedback pot, like that's got that route, that net and that net. So the question is, what's going to benefit from the short trace? Like that's a limitation. Like that trim pot can't be further away from there. That's tied there physically from that. I guess this trace here, from here to that cap. Do I put the cap here or do I put the cap here? Is the question. Does it matter? Possibly, possibly not. I guess I can see what I did in the last time. So I kept the cap up. So I'll maybe do the same as that. These are thick traces, so I think I'll maybe try and keep something much the same, try and keep them the same length. What is that as a... Oh, it's only 0.35. It looks thicker than it is, strangely. And 0.35 is pretty chunky. I guess the limit will be the pads themselves. So that's 0.35. So I could keep with 0.35 as my target trace width. I'll maybe do that because that way it's close to the original version as well. Oops, wrong one. Here we are. Keycard. What am I doing? Where are we? Yeah, that's it. Okay, so that being the case, that goes to that cap. So this cap can go here, potentially. Yeah, let's try that. Because then this runs up there. I guess I might need to juggle that around other stuff, so I might be better having this here, because that'll, to get this neat, this will need to circumnavigate that, so that comes down there, and then this wraps around. This wraps around, goes up to here, to that cap, which then goes to these guys. Yeah, it gives me a good amount of space here for this bit of circuitry. So this I might need to move somewhere a bit more out of the way. That's fine, I can do that. Okay, it's plus 12. Plus 12, that's plus 12. I can bring that down actually. There, and that goes to that side. Let's see how this sits. Interesting. Okay, so that's... Okay, where's that AC coupling cap? Okay, so that's going to... Let's go to there. So maybe that's what I want. So maybe these are the question mark. Move them more out of the way. Maybe. That's kind of close to there, but kind of fine. Nudge it up a bit because I can keep it under that space, that corner. Yeah, let's do that. It's breaching the courtyard, but physically that'll have plenty of space. I guess it will depend on the dimension of this, how that space there. There'll be a better spot. I can move that over. I can move this down, move that over. I can move this all down. There's loads of space. Loads of space. So it's extending those traces. It depends on what's more important. I'm not sure. I think I'm overthinking things. Let's get over there a bit. Yeah. And this could be, could even be like that, if I needed. That would be fine. Let's try that. Let's see how much I can cram in around these guys. Plus 12. Ground. Minus 12. I'll try and star distribute the power as much as I can as well. That should be quite easily done. Put a bypass cap there. It's probably quite sensible. Let's move this. Let's try this down here. Is that a better idea? If I rotate these round. It's kind of 6.5 dozen in it. Like it'll be. Let's try it that way. Okay, and they can be beside each other. Potentially done it. So overall, I think this will be pretty neat. Okay, that is the components placed. So I think what I can do now is just spread things out a little bit, because there's plenty of room. This is at kind of optimal. So things like this, I can move that over a bit like that. Do. Okay, let's add some more bypass caps on sort of important looking bits. So that's a plus 12. Let's move that closer. Yep, that looks pretty neat. Cool. Okay, let's do some routing. I'm going to get a fresh coffee and start back up. Back in a minute. Coffee. So, let's dive into tracing. Routing. In the board file, I can go here and set predefined sizes. So this is where yeah, that's what I want. So net classes, I've got a range. These were imported from the, I think it was the dial project files. I imported that when I was in the schematic side of things. So I just pulled in a bunch of the net classes for power, which cover all the main bits that I use. Plus 5 volts, plus 12, minus 12, ground. There's got a bunch of other ones, including George. Whatever power line George was in that previous board file. Here I've got track widths and clearances. So let's see if I've got any information on this guy. How do I do this in Eagle again? DRC as well? Yeah, here we go. Clearances. So the clearances of that are 8 mil. Whatever 8 mil is. Hey doggy. Clearances 8 mil. There we go, 2.2. So let's just do that same. Track widths will be 1.35 millimeters, and same for power. That's nice big thick traces for everything. VSIs I'll keep the same that I've traditionally used. Can't remember how that's defined in Eagle, but that should do it. That'll give me that clearance and that track width spacing. I don't think I need anything else. I'll probably manually override and draw thicker traces around here. And then when it comes to actually routing, this is the control section here. So this is where I use net class width. I'm going to add a couple of extras. So I'm going to go nice big thick traces from here. So this will be the 0.35 track width. But if I add some extras, find sizes, 0.35, let's go 0.5, why not? Then I can select if I'm locking to something. This is a useful, I'm not sure what they call it, when routing from an existing track, use its width instead of the current thing. So it'll basically override whatever I've got manually selected, and it'll, if I'm pulling from a trace, it will continue drawing at that trace width. So I'll take that off, and I guess here we go. That's actually something I was thinking to try out, is specifying teardrops. I don't know how to turn this on. I've not actually used this feature yet. This will be a Google question. My teardrops in KiCad. Version of KiCad on my own then.
Teardrops in PCB design are small tadpole-shaped features that improve the reliability of printed circuit boards by enhancing the connection between pads and traces, or vias and traces.
Settings.
Zones.
So that's where we apply them. So let's try that. Edit teardrops. Yes. Cool. Okay, so that's added it to all those. Yeah, that's worked. That's cool. I'm going to try that for this board. Let's put this back to the defaults it was at. These are all 1, I think. I should have taken note of what I changed. Oh, it's fine. Let's try this. Edit. Teardrops. And apply. Yeah, that looks good. Okay, it's something to consider, so I can do that after the fact. There's a few things that I'm still trying to get used to with KiCad in terms of how to do things, and also like doing a bit of reading. Like what I would have done before in Eagle, I would probably have routed like that, and I think these are weaker joints. Like with reworking, that's where traces can break the lift, because as that heats there's a lot of strain put on that, because it's a right angle and that's a thin weak point. Whereas if that was teardropped, let's say I moved this, test proof of concept, do that, teardrops, apply. There, that's much stronger now on either end there. I might even pull that down. Yeah, so that's electrically much stronger, and it would look, the solder, oops, the solder mask keeps it just to the pad exposed, and then that's the copper underneath there. Yeah, so that's pretty cool. But yeah, like something I was reading in some articles is actually bringing a trace into the corner of a pad, because naturally that's like a teardrop type shape. So I think that's meant to be quite a good practice to uphold. I don't know what I'm doing. Okay, here we go. Use net classes. There we go, flip-flop circuit traced. Let's do this 501, I'll go back to this size. That's a 5-volt source going to the regulator that's on bypass cap. Ground. 5 volts there, and this I'm going to bring up and around here. This thicker trace width. Make sure to fully avoid the keep out zone. Should be plenty there. To use net classes. My music stopped. What's happened? And add one more plus 12 bypass cap. I'll stick that on the fine-tune pot. Cool. Good boy. go. First signal via. And the other ones are power. So it's pretty good going. One board jump for that whole mixer section. Happy with that. Pretty minimal for copper on the back so far. Good. Getting there. Looks clean. Ground to go. Let's put the ground plane on the bottom layer. So what I'm doing here for the ground plane, select the layer I want, although that can be modified during the process, and then it's this selection here, add fill zone, or option Z, pardon. There we go, that's cool. Bottom copper and net class I'm going to set to ground. Ta-da. Just leave the default settings. Oh, that's drawn from there. Okay, so I want to do this. Set point option Z. Ground. Okay. And then I'm just drawing the outline around the PCB. It will only fill within the PCB dimension, which is fine. Trying to get perfect rectangle, no weird extra vectors in it. There we go. And B is fill. And here we can see we've got a solid copper plane on the bottom. See that there? So any remaining air wires to be connected. You can see any of the existing ground pads, it's added the thermal spokes around it all, like that. So it just means on the top layer I need to find every ground connection and then punch a via through to make connection with that bottom plane. So just work through that. I can set this to being net class. Done. Lots of space to put drawings and stuff, which is cool. So a couple of things I'm going to try here. Let's save this, do a commit. Rootage, 5 degrees. Okay, let's try some fun plugins. So plugins, I think I did this on my laptop last time, so let's go here. Render tracks. Looks neat. This looks a little bit tight on some of them. I used to do this process manually when I was before. Okay, that's saved. Hopefully that's not screwed things up. Okay, I didn't like that. I'm doing the save with a new file. Okay. Okay, so if I reopen the files here. Okay, let's continue digging. Good. Just delete them. Just apply it to the full thing. Let's see where there's bits that look fishy. Get close. Looks almost hand drawn, which is kind of cool. Okay, let's run a design rules check. DRC. 10 errors. Unconnected items. Ah, that's just that. Cool, so no actual real natural errors. These are all just warnings for track is disconnected. This is like a weird issue where there's like not full content. It's multiple bits of routing. Should solve that. Silk screen segment. Yeah, these are all just warnings I can ignore. Delete my markers, close. It's done. That'll work. Cool. Next up's faceplate, and then I can order a prototype, test that out, and hopefully that's a filter design, which is cool. So yeah, that's the process I do these days with KiCad for doing a PCB layout. Although more recent project I'm starting to use 4-layer boards a lot more for denser or more like mixed signal designs, which is a different technique in itself, but a lot of the times I can kind of get away with, oh, that's weird, why is that just a random via on this one, where is that? There, that's going to be a via. Yeah, but this is kind of the process that I still typically do from doing an analog design, something that's a 2-layer board. Yeah, it's pretty fun. Thank you for watching, and if you bought one of these modules, thank you even more, because you've helped this guy. I think moved once during this whole video sequence, so he's loving life.